All right, guys, welcome back to lesson 2.7. This one is about the intermediate value theorem. So last time we talked a little bit about continuity, and continuity is one of the key features of the intermediate value theorem. So now that we understand a little bit about continuity, let's talk about this theorem and how it can help us prove things about functions. So let's get cooking. So the intermediate value theorem, what it says is that if a function is continuous, so notice there it says if a function is continuous, this is specified by the function being continuous. You know what the function has to be? Continuous. If the function is continuous, then you can use the intermediate value theorem. So with that out of the way, what it says is if the function is continuous between a and b. So I'm looking at this function right here between a and b, this interval from a to b, this function is continuous. There are no holes, no other kinds of discontinuities. So if the function is continuous, then it takes on every value between f of a and f of b. So what that means is every possible output value between f of a and f of b, this function will hit it at some point between the interval from a to b. Notice it doesn't specify that it'll hit it one time, it just says that it will reach every value at least once. So here's a way that we can use the intermediate value theorem. So using the intermediate value theorem, explain why this function must have a root over the interval 0, 4. So this function, I know that this function is continuous because it's a polynomial function. So basically what the intermediate value theorem says is that over 0 to 4, this function will hit every single value from f of 0 to f of 4. So let's find f of 0. So f of 0, that's pretty easy. It's 4. Because these are 0, that's 4. Now let's find f of 4. So f of 4 is negative 2 times 4 cubed is 4, 16, 64. So this is negative 2 times 64 minus 6 times 4 plus 4. Really, it doesn't really matter what this number is specifically. What really matters is that this number is less than 0. So the reason that's important is if I notice, if f of 0 is 4, also, side note, let's not write this as an interval. Let's just say that we're going to hit every single value between f of 0 and f of 4. But if f of 0 is equal to 4 and f of 4 is less than 0, by the intermediate value theorem, there must be some value such that f of c is equal to 0. Because the intermediate value theorem tells me that I'll hit every single value between 4 and whatever this number is that's less than 0. Since this number is less than 0, at some point, the value of my function has to be 0. So there's some point where f of c equals 0. Does that make sense? If it doesn't, you can come to me with questions in class. But we're going to do one more example. And we're going to take a look at this example. And we're going to actually set up the function this time that we're going to use the intermediate value theorem for. So what this is saying is I need to use the intermediate value theorem to prove that a real number exists such that x is 1 less than its value raised to the 4th power. So basically what this is saying here is, let's say that I have this f of x, which is, or let's do this. I want to prove that there's some number x such that x to the 4th minus 1 is equal to x. So it would work if I proved that x to the 4th minus x minus 1 is equal to 0. So what I'm going to do is I'm going to take f of x and I'm going to let f of x be x to the 4th minus x minus 1. So what I notice about this is that I notice that f of 0 is equal to negative 1. So because this is a polynomial function and I know that it's continuous everywhere, if I can find an x value where f of x is positive, since this 0 is negative 1, if I can find any x value where f of x comes out positive, then that means that this, by the intermediate value theorem, f of x had to have hit 0 at some point. So what I'm going to do is I notice this is minus x minus 1. That's going to be relatively small compared to x to the 4th. So I'm just going to pick a number, and I'm going to say f of 2. So f of 2, 2 to the 4th is 2, 4, 8, 16. So this is 16 minus 2 minus 1, which is 13. So because f of 0 is -1 and f of 2 is 13, by the intermediate value theorem, there has to be some value where f of c is equal to 0 because of the intermediate value theorem. So because this is less than 0, this is greater than 0, there is some point where f of c is equal to 0 because of the intermediate value theorem. So this is the last example that we're going to do right now, but the first example that we're going to do in class is this problem right here. So I'm showing this to you so you can go ahead and get started thinking about it. So this says let f be a continuous function on the interval 0, 3 if f of 0 is greater than 0 and f of 3 is less than 3. Prove that there is a point c in the interval 0, 3 such that f of c is equal to c. So I'm going to let you guys think about this a little bit before class, see if you can come up with a proof, and hint, hint, you're going to use the intermediate value theorem because this section is about the intermediate value theorem. So that's it for today. Today's only topic was the intermediate value theorem. I hope that you took some notes. If you have any questions, bring them to class. And I hope you have a fantastic day. I'll see you soon.